We are to find the volume that is generated by revolving the region bounded by the curves y equals 8, x equals 0, and y equals x cubed about the line x equals 5. So we are going to rotate that region, which would be this shaded region here, about the line x equals 5. And if we were to rotate it 180 degrees and stop, we would have this mirror image of that region here. Now if we choose an x value, say here, x sub I, and then draw a representative rectangle at that x value, and then rotate about the line x equals 5, that mirror image of that representative rectangle then would be inside of our mirror image region here. And then if we were to imagine that rotation, we would wind up with something that looks like this. That would be a cylindrical shell. Now, because that's very cramped and I can't really see it, I'm going to redraw it using my representative rectangles a little bit larger so that I can see it and work with it. So that rotation would give me something that looks like this. And this would be a cylindrical shell, and the thickness of this cylindrical shell would just be the width of that rectangle that I drew, and since that goes from left to right, that would be represented as a delta x width. So x is going to be our variable of integration. Now, if we were to cut this cylinder and open it up and lay it out flat, we would wind up with a rectangular figure that would be three-dimensional, and we could find the volume of this rectangular figure just by multiplying the length times the height times the depth. And the depth we know is delta x. The height would just be the height of this cylinder, which would be the distance from the line y equals 8 down to the curve where I have this x coordinate x sub I. So that would just be the y coordinate of that point. So that height then would be the value y equals 8 minus the y coordinate y sub I for that representative rectangle. But if my variable of integration is going to be delta x, is going to be x, then I need to express this y value in terms of x. But we know that y and x cubed are exactly the same thing on that curve. So this height can be represented as 8 minus x sub I cubed. So this height then is 8 minus x sub I cubed. Now the length of this rectangular figure would just be the same as the circumference of the cylinder. And circumference has a formula, 2 pi r. So we need to know that radius of that cylinder. That would just be the distance from the line x equals 5 to our representative rectangle, and that would be the x coordinate of that representative rectangle. So that length then of this three-dimensional rectangular figure, which is the same as that circumference, would be 2 pi times 5 minus x sub I. 5 minus x sub I would be that distance from the curve to the line x equals 5. So now the volume of that one representative cylinder would be v sub I equal to the product of these dimensions. So we would have 2 pi 5 minus x sub I times 8 minus x sub I cubed delta x. And we could approximate the volume of the entire three-dimensional figure that would be generated by rotating that shaded region about the line x equals 5 with a sum, a finite sum, I equals 1 to n, of these products. And that would be an approximation, not an exact value. The exact value we could get with a limit. So the exact volume we could express as v equals the limit as n goes to infinity, sum I equals 1 to n, 2 pi, 5 minus x sub I, 8 minus x sub I cubed delta x. And this we know is the same as the integral, v equals the integral from where we start. Well, our left endpoint of this region, the x coordinate of the left endpoint would be x equals 0, and it would end at x equals 2. 2 is where the graph of y equals x cubed and y equals 8 would cross in that quadrant. So our limits of integration would be 0 to 2. Then we would have 2 pi, 5 minus x, 8 minus x cubed dx. And now we could multiply this out to make it a bit easier to integrate. So we would have the volume would be 2 pi times the integral 0 to 2, 40 minus 5x cubed minus 8x plus x to the fourth dx. And now integrating, we would have 2 pi times 40x minus 5 fourths x to the fourth minus 4x squared plus 1/5 x to the fifth. And that would be evaluated from 0 to 2. We should get 504 pi over 5. And that would be the volume that would be generated by revolving that region about the line x equals 5.